In 1984, Xilinx introduced the world's first FPGA, the XC2064. When the product was released, Xilinx employees were given some homework. Draw a circuit using the XC2064 64 configurable logic blocks. Those circuits could be drawn with pencil on paper. Less than 40 years later, AMD is now building Kria K24 System-on-Modules with 154,000 logic blocks, and 6 ARM cores, and 2 gigabytes of DRAM, and a graphics processor, and a deep learning processor, 132 IOs, and 4 USB ports, and 4 Ethernet ports, and, well, so much that thankfully you won't be designing your circuits with pencil and paper. But after adjusting for inflation, they don't really cost much more than those original XC2064 FPGAs. Incredible. Stick around to learn more about these amazing SOMs from AMD. Welcome to Tech Chat, sponsored by Mouser Electronics, where we chat with engineering experts about the latest technical innovations that are shaping and reshaping our world. Today, we welcome back a friend of the show, Chetan Khona, Senior Director of Industrial, Vision, Healthcare, and Sciences at AMD. Welcome back, Chetan.
Thanks, Dale. Great to be back. I think this is my third Tech Chat, so glad to talk to you some more about Kria SOMs.
Yeah, so what do you have queued up for us today?
Well, today we're going to be talking about the new K24 SOM and the KD240 Drives Starter Kit, part of the ever-expanding Kria SOM portfolio of system-on-modules.
Well, I know I enjoyed our last talk about the Kria SOMs, so I'm looking forward to today, so let's get started.
Yeah, so Dale, the reason we're talking about Kria SOMs in the context of electric motors and drive systems is because electric motors are everywhere. You see them in public transportation, you see them in wind turbines and other power generation systems, to robotics on factory floors and in warehouses, to medical equipment, and also to aerial systems used in agriculture. These motors are responsible for a staggering number, 70% of the total global industrial energy consumption number. And even though modern motors are more sophisticated, offering features like variable speed capabilities and increasingly being designed with materials like gallium nitride and silicon carbide, as well as others, these are done to improve the efficiency and performance characteristics of these applications while significantly reducing power consumption. With that said, to maximize the return on investment of these systems, faster and more sophisticated switching is required from the electric drive systems to control these motors, and that's where the K24 comes in.
It's really fascinating. I mean, moving to renewable energy sources is important and gets most of the attention, but this highlights really the opportunities for reducing energy consumption, which were part of the overall challenge of making our lives more efficient.
Absolutely. Many factories can have hundreds of motors powering robotics that drive assembly lines or other equipment in a single building, factor in energy consumption attributed to motors on subways, building heating, ventilation, and air conditioning systems, consumer applications, construction, logistics, energy generation. It's pretty much no wonder that experts consider improving the efficiency of these applications to have the single largest impact on worldwide electricity usage, to the tune of anywhere from 15 to 40% on a per application basis. So the question we asked ourselves was, what does even a 1% savings look like in terms of money and sustainability impact? So using the half credit card size Kria K24 SOM from AMD, you can cut power consumption, increase torque, and other performance characteristics while reducing motor noise and vibration, employ predictive maintenance with over-the-air updates for a longer service life with each and every motor. And this is all possible through high performance and power efficient DSP capability. The K24 has over a 2x latency advantage. It complements the K26 SOM with connector compatibility. And one of the best things about Kria SOMs is you don't have to be an FPGA expert to use them. Just like prior Kria SOMs that were geared for software engineers or AI scientists or robotics, the K24 supports Python and MATLAB Simulink flows for control systems engineers, in addition to traditional FPGA flows.
Now, you had mentioned in the previous slide that you were designing these to improve the efficiency of motors, but here you mentioned predictive maintenance and that kind of thing. So is that also part of the planning for these Kria SOMs?
Absolutely. So Kria SOMs can be used in a wide variety of applications. Now, when we talk about predictive maintenance, it's a short connection to getting into the world of AI inference. And as you are quite aware, I'm sure, Dale, AI is all the rage in 2022 and 2023 and moving forward into the future. One of the things that we also recognize that, yes, you can do AI, you can do predictive maintenance with a K24 SOM, but it's just as likely that the K24 SOM is going to be used in creating a lot of the data, because obviously for AI to be used on data, something needs to be creating the data. And I think with the K24 being used in systems that are right next to that analog digital boundary, it also would be equally used in generating data as well as consuming the data that it's generating.
Oh, that makes perfect sense. Yeah.
So Dale, the K24 SOM is complementary and extensible to the K26 SOM because it's based on the same Zinc UltraScale Plus MPSoC architecture. That means you'll get the same quad-core A53, the same dual-core R5 processor with terrific peripheral set, and inside the SoC, you're going to get a hardware root of trust for cybersecurity support. Really, the K24 is a scalable option from the K26, where size, cost, and power efficiency are the primary design criteria.
Now, you talked a little bit about how the K24 and the K26 are similar. How are they different?
Yeah, so there's a couple key differences between the K24 and K26. Number one is you've got about 100,000 fewer logic cells. So the K24 has got about 150,000 logic cells. The K26 has got about 250,000 logic cells. The K24 supports Ubuntu 22.04 server versus the K26 supports Ubuntu 22.04 desktop. You've got a little bit less I/O in the K24, and we'll talk about I/Os and connections hopefully a little later in our chat. And you've got 2 gigabytes of LPDDR4 compared to 4 gigabytes of DDR4 in the K26.
So, Chetan, you've introduced us to what a SOM is, basically, and all the functions. Can you tell us now about how a SOM works and how somebody would use that in their system development?
Yeah, absolutely, Dale. For those that are maybe not familiar with the system-on-module concept, SOM speed our customers' time to market by enabling hardware developers to focus on their application differentiation and enable software developers to start sooner with pre-built hardware. So even though Kria SOMs are intended for production volumes, we offer starter kits that house these Kria SOMs so our customers can quickly prototype their application while they design their own custom carrier card for the production SOM to plug into. Now, if I use robotics as an application example, you can see how you can use the various kits to prototype a full robotic system very rapidly. Starting with the KR260, you could have that be the brains of the robot doing functions like motion planning or navigation. The KV260 can be the eyes, maybe inside of a camera, running perception to aid with the navigation. And the KD240 can essentially be the muscles controlling movement and actuation. After prototyping, you can take those designs to production with a mix of K26 and K24s. And especially in an application like robotics, which is sometimes referred to as the art of systems integration, you can see why having these modular building blocks made up of adaptive computing ingredients is such a powerful concept in a distributed embedded system such as robotics.
And I would encourage anyone who's interested and wants to learn more about the K26 SOMs, go back and check out our previous tech chat, and we discussed that product family in great detail.
Yeah, so introducing new users to adaptive computing is really the goal of Kria SOMs. And again, just like the last slide where we were showing robotics, like if I'm going to stick with robotics as a theme or an example here, you can see how AMD is engaged at every level, starting with teenagers in their schools in over 30 different countries all over the world with the first robotics competition. Kria SOMs are also a key component of the AMD University program, our association with the world-renowned robotics incubator Mass Robotics, commercial engagements with some of the largest industrial companies on the planet, and we're also glad to share that the K24 SOM will be used by the AMD-sponsored team Switchback on the next season of BattleBots, which is a very popular show that airs on television all over the world. So really, our goal is to have Kria be the entry point into adaptive computing for customers, really regardless of age or background.
And it's really staggering to me to think back to my own career, what computers that I was using in high school compared to what they can use at Kria today is probably 100,000 times more performance.
Absolutely. It's amazing what you can do, and you can do on a very small form factor. Again, the K24 is only half the size of a credit card, so very compact.
Absolutely.
So moving beyond robotics, Dale, there's lots of other applications that the K24 can be used for, from power generation to medical devices to public transportation. And the common theme across all these applications is not just motor control in every one of these, although there is a dominant theme. It's also DSP intensive applications. Take EV charging, for example. You're not necessarily spinning a motor, but you are controlling an inverter, and the control loops and the control theory behind that traditional motor control are very, very similar. And there's lots of other applications not listed here. 3D printing systems, for example, and many, many more.
Yeah, this is a pretty broad span of industries and applications. And it's just a reminder that, as you just kind of alluded to with EV charging, is that even though the application from the front might not look the same, behind the scenes, a lot of the math, a lot of the algorithms, a lot of the computation has a lot of things in common. And so there's advantages there of building things on the same platforms. If I think of development teams, if they get used to the same platforms and use that over and over again, there's efficiencies for companies where they can scale a product like the K24 or the K26 across multiple product lines.
So like we've been mentioning, the Zynq UltraScale Plus adaptive SoC is used in the K24 SOM. However, it is specific to the K24, so it's not one of the standard devices found in the Zynq UltraScale Plus chip-down product portfolio. It has capability for mixed criticality, where some user functions can be given real-time priority and others best effort or anywhere in between. Very important for functional safety critical systems. We've also built in hardware root of trust for cybersecurity in the SoC itself, but it's augmented by a TPM 2.0 on the SOM. And you've got visualization capabilities with a built-in display GPU. So really everything you need for a robust industrial system: functional safety, cybersecurity, and HMI.
So, Chetan, you've been talking about all the things that the K24 SOM can do, kind of all the things inside the device itself. How does it communicate out to the world so you can integrate it into these systems we just talked about?
With the programmable I/O structures of the device, you can connect up to virtually any sensor from environmental, orientation, vision, or otherwise, and you can drop an IP to support industrial networking. For those that are probably not familiar out there, there's over 40 industrial networking standards out there. We offer support through our in-house developed time-sensitive networking. Some people know that as TSN IP, or third-party IP for EtherCAT, Ethernet IP, and a much longer list.
And one of the things that interests me, as we're here from all about circuits and we like to know what's going on, how do you get all that kind of functionality into a single product like this? It's half the size of a credit card.
Yeah, so the K24 SOM is enabled by something called info packaging. Now, info packaging was something we introduced not that long ago for the Zynq UltraScale Plus family of adaptive SoCs. And info stands for integrated fan-out, where there's no traditional substrate in the design or manufacturing of the chip. So in a traditional BGA, you've got the active silicon, you've got a substrate, and then you've got the balls, some plastic around it, of course, as well. With info packaging, you don't have that traditional substrate layer, so you're going from the active silicon down to balls connected up to your printed circuit board. AMD is one of only 2 companies that we're aware of on the planet that have access to this capability and this technology through our fab TSMC.
I know in my recent years, just keeping track of the technology inside the chips, it's almost equally as fascinating to see the advances in packaging technology, because they really are engineering marvels in their own way.
So Dale, how long has it been since you've been at college in an engineering course?
Oh, it's probably been about 30 years. So that really dates me pretty aggressively.
Well, strangely enough, it's probably been about that same amount of time for me as well. So this slide gets us to something that we might have both seen in the 90s as we were taking our university courses, really around processing architectures, right? So on the left, you've got a standard DSP processor, which is your sort of sequential ALU based architecture where you're cycling through and to get to the conclusion of a pretty typical DSP operation, let's just call it a multiply and accumulate operation, it'll take X number of clock cycles. In the example here, right, we've got 200 clock cycles needed. On the right, though, you sort of get to the heart of the fundamental advantage that FPGA and adaptive computing in general have when it comes to DSP applications. And this is really around the parallel architecture. The FPGA capability in an adaptive SoC can make that operation fully parallel. And there's really 4 major implications to this. First and foremost, latency. In this example, instead of 200 clock cycles to get to the result, you can get to that result in 1 clock cycle in the K24. Second key attribute, power. To get to the result as fast as possible in the DSP processor, you really have to speed up the clock and run in the hundreds of megahertz or even into the gigahertz range, versus with the FPGA, you can run the circuit much slower. oftentimes less than 100 megahertz, and still beat out the DSP. Number 3, adaptability. AMD gives you the ability to trade off power, latency, and clock speed to tune to meet your requirements. For example, we have the ability to do more than 200 operations in one clock cycle in the K24, but you don't have to use all the hardware blocks up if you don't need to. Instead, you can time multiplex the hardware blocks and maybe take 400 operations across a number of clock cycles and really kind of decide how you want to tune for power, latency, and clock speed. And then lastly, each DSP algorithm can be implemented independently and resources don't need to be shared. So when you're dealing with multiple control loops running simultaneously in a device, you can do that much better versus in a standard DSP processor. You may have a fixed number of MAC units, but at some point you'll run out of MAC units and you'll have to share those units across a fixed number of control loops. And that can be problematic when you run into interrupts and other sort of interruptions. So the independence is very key in a adaptive approach.
Yeah, and this highlights another kind of trend in the industry. As it used to be, it was just always pushing performance, performance, performance at the expense typically of power. But now, because things like the Kria SOMs have such high performance and the adaptability, is you can do much more with the trade-offs of power and performance to make these things power efficient, which is part of the overall system goals, as well as meeting the performance requirements to accomplish whatever the tasks are.
Someone told me a long time ago, Dale, that engineering isn't the Olympics, right? It's not about being the absolute best. It's about meeting the specification. And a lot of times the specifications are not one-dimensional. They're hitting a particular performance within a power envelope. And so you're able to make those trade-offs and control the architecture of what you design an adaptive solution.
I like that analogy. So one of the things you talked about on this slide was latency. Can you give us a little bit more detail on, how that latency is affected and where that's important?
Yeah, absolutely, Dale. So one of the things that we just talked about on the previous slide was having multiple control loops, right? And the resource contention associated with that. By offloading, let's say in a motor control application, multiple axes of control to independent control loops that are running unconnected to one another other than through management by the application processor, you're able to get the most determinism and the lowest latency processing available. And then the K24 SOM, the features the ability to also have cache coloring, which also even aside from the get out of jail free card that is the programmable logic, you also have the ability to prevent cache flushes and cache misses in terms of affecting your latency. So that really adds up in a real life application. If you're looking at a single axis drive application compared to a traditional DSP type architecture, in this particular case, this AM6400 series device, you're getting up to 2x lower latency in a single axis. Now, if you go beyond a single axis and you go to 3 axes, let's just take 3 axes, for example, you're going to get up to a 7x latency improvement over a traditional DSP type architecture. And that improvement will continue to grow as you add more axes of control until you get to the point where there's another bottleneck in your system. Maybe it's the communications, your Ethernet or something else that will be the bottleneck in your system. But, certainly would never be the adaptive computing block because, again, you're implementing each control loop independent of each other in the FPGA fabric. And the K24 has significant power advantages when compared to other popular SOMs out there. Some of the other, popular SOMs out there on the market today are GPU-based SOMs. And when you take a look at what, the power envelope of the K24, right, can be as low as 2.5 watts, you're getting anywhere from a 4 to 6x advantage over, some of the lowest power GPU-based SOMs that are popular on the market.
That's a reminder. The GPU has been, pretty revolutionary as far as what it has done across so many markets and industries, but it doesn't solve all the problems the most efficiently. Back to your Olympics discussion previously, is that, you want to do these and optimize across a number of metrics. And of course, power needs to be one of those.
And one of the great things about the K24 SOM is you don't need active cooling. I don't know how many GPU-based SOMs can say that.
Absolutely correct. All right, so we've been talking some about the benchmarks and the power and what goes on inside. Now let's shift gears a little bit and talk about how a user starts integrating these into their systems.
Yeah, thanks, Dale. So, one of the things that we touched on briefly earlier, and I want to come back to because I think it's my personal favorite and what will probably be our customers' favorite feature of the K24, is that you can easily swap from the K24 to the K26 or vice versa, thanks to a little bit of foresight by our engineering team. So both the K24 and the K26 share a 240 pin connector. This 240 pin connector by Samtec are electrically and architecturally compatible with each other. So if you lay out a printed circuit board that only requires the 240 pin connector and nothing else, you can actually seamlessly migrate between the K26 and the K24. Now, also, if you have a multifunction circuit board that will maybe need more IO in an expanded use case, right? You can actually lay it out where if you plug the K26 in, you get access to both 240 pin connectors. And if you only plug in the K24, you only get access to one of the 240 pin connectors. The K24 also does have an optional 40 pin connector on it. And the reason we did that was as we kind of went through the application use cases that the K24 SOM could go into, one of the things that we saw was there was a little bit of meat left on the bone with respect to IO coming off the chip, and we didn't want to cut corners with respect to the IO enablement for the end user. So we wanted to make use of that through that 40 pin connector. But again, it's still a very powerful concept. You can lay out the mounting holes as well as the connector to be able to swap between the K24 and K26 and really get a lot of scalability.
Now, you mentioned the applications that you were building for, and I know part of this was about motor drive. So let's talk a little bit, if you could, about motor drive applications specifically.
Absolutely. So in this presentation, I think we probably spend a little bit of time talking about brushless DC motors. And certainly those are the most popular type of motors out there. Servo motors, which are often a form of brushless DC motors, are absolutely the de facto standard used in a lot of robotics applications. But it's important to note that the K24 can control any one of the motors that are shown on this slide with the same features and benefits that we've talked about throughout our time together here, Dale. So just because we may be talking about brushless DC, don't feel bad if you're using a stepper motor or you're using one of the other motor types listed here.
Okay, so I've seen all the features. I'm sold. I want to get started. You mentioned previously the starter kit as the place in that development cycle. So maybe you could talk to us about that starter kit.
Sure. We call the starter kit for the K24 the KD240 Drives Starter Kit. It enables a developer to work with the K24 SOM, and specifically in the case of motor control, you can be up and running, controlling a motor in well under an hour. And as you probably saw earlier from our talk, a developer can work with the starter kit while their hardware team is creating a custom carrier card in parallel so they can get their embedded design completed much faster than the traditional chip down approach. A couple other things I'll mention is the starter kit. Obviously, if you want to control a motor, there are going to be multiple motor control accessory packs that are going to be available, and we'll talk about those maybe a little later on, Dale.
Well, I look forward to hearing more about that.
So first of all, it probably is worthwhile starting with a block diagram overview of the KD240 Drives Starter Kit. First of all, it's worth mentioning if you've used any of the Kria starter kits that came before it, they're all roughly about the same size. You can hold them in the palm of your hand. This particular kit, if you look along the top edge, you've got micro SD, multiple USB, multiple Ethernet. You've got both best effort Ethernet as well as deterministic Ethernet connections that connect up directly to the programmable logic. You've, of course, got CAN, which is a mainstay in industrial systems. Then along the right and the bottom, we have dedicated connections for motors and sensors. And then back over to the bottom left, you've got a PMOD connector for expansion. So really everything you need to get started, certainly for motor control, but there's lots of applications that even if you aren't doing motor control, the KD240 might be an interesting starter kit for you.
You mentioned that you can conceivably start development and get something up and running in about an hour. What would that look like?
Really, it comes down to 5 simple steps, right? With the dedicated connections on the KD240 and the motor control accessory pack, along with our getting started guide and other resources we make available, it's really straightforward to get up and running. And if you've used our previous starter kits or familiar with them in every way, the feedback has been extremely positive. And even more so than that, a standard familiar flow for embedded developers, right? So we're not trying to create a new and different, air quotes, better flow. What we're actually trying to do is create a standard familiar flow so it just makes sense to the users out there.
And you mentioned the developer flow may being very standard. Can you talk a little bit more about that developer flow and the tools behind it?
Absolutely. So the tools and the flows behind it, first of all, really we have a number of different development tools for any type of user out there, right? So whether you're a traditional FPGA designer that's used to developing custom RTL, whether you're developing in C, C++, you're a roboticist developing with ROS2, a control system developer developing with MATLAB, MATLAB Simulink, an AI developer, TensorFlow, Caffe, PyTorch, etc., or you're a Python developer, we have an entry method for you that lets you get up and going with Kria System-on-Modules. Obviously, we're highlighting Python developers and control system developers because they're the most common types of developers that are going to be doing motor control type designs. But certainly, if you've looked at our previous kits, we've targeted different developers with each kit. And the great news is that any one of our kits will support any one of the development flows shown on this slide.
It's really interesting to me how the different application spaces and different industries have all kind of centered around different tool sets. And I guess it makes sense for solving different problems, but it's fascinating how there's this, as you've highlighted so well here, different entry points based upon where you're coming from in your experience or the problems you're solving.
So I alluded to the optional accessories available for the KD240 earlier. On the left is the KD240 motor accessory pack available at launch, which offers a precision quadrature encoder so you know exactly where the motor is at all times for field-oriented control applications. It is a brushless DC motor that will 24 volts. Again, this is available today for purchase. Coming soon is another bundle from Rev Robotics, one of the leading names in STEM education. We talked earlier, Dale, about the importance of education both at the high school and university level to AMD. We've bundled their Neo 550 brushless DC motor. This does not have the quadrature encoder. It has Hall sensors, but it does include a gearbox and a 2-in-1 kit. So you can make fun projects like a foam ball shooter or a simple robotic arm. And while these are fun projects, and I'm sure I can already picture cubicle mates throwing balls at each other across the hall, these are inherently unstable systems that require DSP processing of the highest magnitude to produce consistent outcomes. And frankly, with this kit on the right, you can even optionally attach a USB camera to the KD240 to use a little bit of AI to help with targeting the ball launcher. The kit will be available to order later on this year.
So here you've highlighted some of the hardware that's available, but you've been alluding to and talking about throughout this presentation that it's not just hardware, but it's also the software solutions you have. Could you talk some more to us about the software and the apps that you have available to support people getting started?
Absolutely. Like a lot of things, right? To really create a complete solution, it's really about the electronic embedded hardware, the actual physical hardware itself, which we just talked about with the motors and the kits, but then also the App Store, right? So when we first launched Kria System-on-Modules back in 2021, humble beginnings. First and foremost, it was a very limited offering with respect to the App Store. But then going beyond that, the whole concept of an App Store for a company like us to put out was sort of I would say a paradigm shifting sort of move. Fast forward a couple of years, the App Store now with the addition of the KD240 is poised to have over 25 apps available. All are containerized, supporting Ubuntu Linux, and are deployed from a Docker hub.
All right, Chetan, as we near the end of our discussion today, maybe you can give us a kind of a summary of what we've talked about and the key takeaways that people should take from your presentation.
Absolutely. Thanks, Dale. Thanks for this opportunity. But I would say, in summary, AMD has expanded the Kria offering to include a range of complementary products, including 3 starter kits and the K24 and K26 SOM. We think this portfolio offers options for different use cases, different development flows, options with respect to price, power, and size for a wide range of embedded production products out there. Also, customers can purchase any of these products online at amd.com, various online distributors, and through traditional distribution channels. Now, we think that the introduction of the K24 SOM will not only be a great product in and of itself, but the scalability opportunity that our customers will have will really, I think, produce a multiplicative effect across the portfolio. And, like we talked about before, right, and you can see it from the KD240 Drives Starter Kit, the K24 is low power enough to not require active cooling. You can see prices here. Prices are standard and flat across volumes. So we try to make it very accessible for small and medium-sized businesses.
And you highlight something here that we haven't really talked about, but that really makes sense in the applications we're talking about, is that you do have not just commercial grade, but you have industrial grade versions, which is obviously going to be important in these factory, transportation, industrial environments.
Yeah. And really, one thing that I probably failed to bring up earlier, and I'm glad you brought it up, Dale, is that, certainly temperature range is sort of the foundation of industrial grade versus commercial grade. But we've snuck one additional feature into the industrial grade K24 SOM only. And the industrial grade K24 SOM has ECC protected DDR4, LPDDR4 memory on the system-on-module. So for those critical applications that really need to have the lowest fit rates or the highest reliability possible, having already the ECC protected memory that's already inside the Zinc UltraScale Plus SoC, but now also bringing the ECC protection externally to the LPDDR4 is something that you're only going to get on the K24i grade.
Excellent. And that makes perfect sense in those kind of applications. It just fits in with those more demanding requirements. Well, why don't you give us some kind of key takeaways as we wrap up here?
Yeah, I would say, just to recap, we're expanding the Kria SOM portfolio with the K24. It is, as we've talked about quite a bit, optimal for motor control, but also really any other DSP intensive applications. You can also do some AI inferencing on it as well. And you can get the orders in right now for the KD240 to prototype your design that'll go into production with the K24 SOM. So we think that the K24 not only supports our robotic strategy, but can also play a small role in reducing industrial energy consumption, which is something that we talked about right up front, Dale.
Well, as always, Chetan, it's great talking to you. It's great to hear about all the amazing technology that AMD is bringing to market and really making accessible. So that's really exciting. So as we wrap up today's Tech Chat, we do want to thank our sponsor, Mouser Electronics. If you're looking to purchase any of these great AMD products or other electronics components and supplies, I would encourage you to head over to Mouser.com to thank them for supporting educational presentations like this. And join us again next time on Tech Chat, where we chat with the leading technical experts like Chetan Khona from world-leading innovators like AMD who are changing our world every day. Thanks, Chetan.
Thanks so much, Dale.